Hello. So today we are going to look at how to solve systems of equations, especially in more than two variables, using a wonderful tool that you can find online called WolframAlpha. So to start with, we need to understand how to turn the problems into a language that WolframAlpha can understand. So we're going to start actually with a simple 2x2 system. That is two equations and two unknowns. Okay. Now it needs to be transformed into what is called an augmented matrix for WolframAlpha to be able to interpret it, as well as this is how they will output their answer. So what this does is that each equation, will become a row of our matrix, which is essentially just a grid of numbers. Okay. And each variable will become a column of our matrix with a further column for the portion without a variable that is what the equation is equal to. Now, because we are doing this by variable, you need to be very careful that your equations are organized so that all the x's are on top of each other, all the y's are on top of each other, and so on. So we're going to put this into a rectangular grid of numbers called a matrix. The first equation has a 1x, a 2y, and a 7 on the other side of the equal. Okay, so again, these three numbers come from my first equation. Okay, what column each of the numbers is in corresponds to which variable they were attached to. So a 1, a 2, and a 7. Our second equation has a 2, a 1, and an 8 for the coefficients in order. All right, now I'm going to open WolframAlpha. Now I'm recording this on an iPad, so I've paid the couple dollars for the iPad app. Absolutely worth it, in my opinion, by the way. But you can also go to WolframAlpha.com for a free version on anything that can access the internet. So here is how I'm going to type this in to WolframAlpha. I'm going to write RREF. This is an acronym that stands for Reduced Row Echelon Form. You don't actually need to know that, though. This is just what we put in to be able to solve a system of equations. Okay. Now, for WolframAlpha, to interpret matrices, we're going to use the curly braces, and each row and the matrix itself will start with a curly brace. So a curly brace to start the matrix, a curly brace to start the first row, and then I will enter in the numbers from the matrix in order with commas separating them. Then a curly brace to end the row, comma, starting the new row. 2, 1, 8 are its entries, curly brace to end the row, curly brace to end the matrix. Now, what I like about WolframAlpha better than, say, a graphing calculator is that it immediately outputs what it thinks I typed in, which is a matrix, and I can make sure that the matrix that I typed in is the one that it gave me, which it is, which means I typed it in correctly. So then below that, under result, there is another matrix, which I will copy down here, and that is this. Okay. Now remember, each row becomes an equation, first column for x, second column for y, third column on the other side of the equal. So reading this back, the first row literally says 1x plus 0y, otherwise just known as x, equals 3. 0x plus 1y, otherwise known as y, equals 2. And I have an answer to my question. Okay. All right. So we're going to practice a couple more of these. Okay. To make sure that we have it down. This time I'm going to do what I call a 3x3 system, which is 3 equations and 3 unknowns. Okay, so first, to translate to a matrix, I'm literally lifting the numbers off of each equation in order. Okay. All right, now I'm going to go over to WolframAlpha. Okay, and I'm going to type that all in. Okay. So, reduced row echelon form of 3, -2, 1, 15, -1, 1, 2, -10, and 1, -1, -4, 14. Okay. Again, once I have hit enter, I make sure that their initial matrix and my initial matrix are the same. For instance, that I didn't accidentally drop a negative sign. And their answer then reads that x is 5, y is -1, and z is -2. Okay. All right. One more to make sure that we've really got this. Now this one is going to have a feature that my previous examples have not, and that is that this third equation is missing a z term. Now, because it is missing a z term, notice when I wrote it, I left a space so that the x's, y's, and z's all still lined up in what look like columns. When I go to turn this into a matrix, what I will have to do is then put a 0 in the z column of the third row to guarantee that empty space, essentially. All right, so now I go to WolframAlpha and I type in my matrix. All right, making sure that what they think I typed in matches what I think I typed in, and then reading off my answer of x equals -6, y equals 8, and z equals 2. There are ways, of course, to solve these by hand. Please take my word for it that you do not want to have to learn those ways. They require an awful lot of work, and they are messy, and they're very, very easy to make mistakes on. So given that I do not have a week of time to devote to making sure you can do these right, we're going to always make use of WolframAlpha's ability to solve them for us.